Okay, so I disassembled the rod clamp, took it off, had to pull everything up off of the rods, and then I pulled this out of the hole, and I see there's really not much soil attached, so it's not a very sticky clay. So that zero cohesion is probably correct. You know, it's sandy, silty enough that nothing even sticks to the plates. Don't really see a lot of clay sticking here. If this was a fat clay with some cohesion, we'd have a clay surface here. We'd see the soil, this clay on clay or soil on soil shearing, letting us know that, yeah, the shear surface was in the soil. That's why these ridges are sharp, so that the soil, you know, this rides against the soil. Once it's fully inserted, we don't have the partial seeding problem. Once it's fully seeded, it's shearing soil on soil. So just want to clean it off. Going to rotate, put it back in the borehole. I think I did north-south last time, so I'll do east-west, and we'll repeat the test. Okay, so the other thing is you may want to clean this soil off the top and make sure we're not trapping any soil in here. If we expand the shear head, get that cleaned out. Any soil trapped on the top is going to be an extra weight. It's going to add to the tear value, and if it falls off during the test, that's going to change things. So best to get this cleaned off. Insert the shear head, go east-west this time. I think north-south is what we started with. Normally I'd have that written down. Okay, pull this over and down. Remember not to pull on the cross plate when you're manhandling this. Kind of get it lined up nice, centered over the borehole. Vertical. Use a bubble level if you really want to be accurate, and then rotate this back up to the top, towards the top. Insert the Acme rod, pull rod, the Acme threaded rod onto our pull rod, our rod clamp with the plus indentations down, about pull up the shear head an inch. So now it's going to be hanging. Okay, lock that in. This is where I might use vice grips on an older unit to help clamp these together as I tighten this. Just give you some more clamping force. Make sure that's tight. And then rotate your rod, make sure it's locked into the rod clamp. Okay, it's locked in there, good. And repeat another test. Okay, have my brightness turned way down. Recording here. So I'm at some value of normal stress here. I'm going to retract. I'm going to now turn that back to auto. As I connect this, that's going to bleed that pressure off. It's going to give it a 0 volt command. Get down to 0. We're in auto mode. We can now go to expand. I need some supply pressure now. And give several cranks here, 5 or 6, and set it up. I'll go through the next test, and I'll just show you what's happened at the end. Okay, so this is the end of the second test. At one point in the blue curve, number 4, I was adjusting the stepper motor box, just looking at the flexibility, seeing if we need to increase the belt tension. And then I realized the test was still running. So you see a little hiccup here on the blue curve. That was me. So that 4th point may be slightly elevated because I was too eager in doing that before the test was done. But here, okay, we got a friction angle 34 degrees. We have this intercept cohesion minus 3.7, half of a psi. Essentially, I'd make that 0, just like the last test. If we throw away the first point and say that was partial seeding, they're still pretty lined up. It makes the friction angle 33 degrees, and then if you force that to 0, you maybe get a slightly lower friction angle there. But then you can also see the R squared, as you add or subtract points. If we say the first 2 ones were partial seeding, then I think that friction angle is getting kind of low compared to the previous test. So 33, 34, 5 degrees. Not exactly the same one, but fairly consistent. And our linearity with the R squared at 0.99 is really good for soil. So slightly different in these two orientations, but you could take the average of those. At the end, I'll take a screenshot of this so you can see the final configuration of the screen at the end of the test. But at this point, you know everything needed to run a test, and I encourage you to just try some trial boreholes before you go to the job. Make sure everything is working. You definitely connect all the equipment, put it together before you go to the field, and make sure everything's functioning. You don't want to get to the field to find out that the stepper motor is not working all of a sudden or some reason. One thing that happens is the USB to serial converter that this computer talks to the stepper motor with, sometimes Windows will update, and then the manufacturer of that device, that USB to RS-232 converter, they need to update their drivers to make it work with the new Windows version. So sometimes you may find you did a Windows update and all of a sudden it doesn't work for the stepper motor. You need to update that driver. Occasionally the manufacturer stops updating, and like when we went to Windows 11, we actually just had to locate a new USB to RS-232 interface and switch over to that one. Hopefully this one that's we're currently using will be on top of things and will update with Windows, but always be careful about Windows updates. You may want to make the settings on this laptop to not automatically apply all updates. Maybe just notify you, and then you can choose when to do those. Always check it before you go to the field. One last thing on that driver update. If I hit Windows key and type updates, and then I get to the Windows updates, if Windows does an update that makes the driver not work, there's some updates here for the Windows security and then a .NET framework. You will not see the drivers for the USB RS-232 connection until you hit Advanced Options and then go down to Optional Updates. If there was an update for the driver of that USB RS-232 connection, you would see it here, and then in the past we've found it here, applied it, and then the driver starts working again. So it's basically between that device manufacturer and Windows, keeping up with each other. But any computer you use for field testing, I would always set it to not automatically apply the latest updates in Windows. Go ahead and apply the security ones, like for the what is it called, Windows Defender, but just notify you on the other ones, and then you want to check those one by one, apply them, make sure things still work before you go to the field. Don't go to the field and then find out that a driver update was your problem. But that's everything you should need to run a set of tests. And please send an email if you have any questions. We can help you get through any hiccups. As if you're a person who does field tests, something always goes wrong in the field. It's Murphy's Law. You go to the field and you need some duct tape or something to fix a problem just about every time. Oh, I will note one thing. In this test, I noticed the shear plate was a little inclined. So normally you would go ahead and spread some sand underneath the plate to level it, or use a shovel, level the ground off, maybe even put some 2x4s there. Probably the easiest method is just to spread some fine sand down there, like playground sand. In this case, I noticed the shear plate, the base plate assembly was a little tilted, so I took some wrenches and just shimmed it up there so that it was a little more level, and that way it was pulling the rod, more vertically out of the ground. And that helped with this test. There was no grinding of gears, and everything went pretty smoothly. Okay, thanks.